Welcome back, everyone. In today's lesson, we're going to be covering implementing some logical operators in terms of reduce. As always, the prerequisites for this video are a basic understanding of JavaScript, as well as some familiarity with ES6 syntax. If you find yourself lost at any point in this video and haven't been following along, please check out the prior videos in this series. The logical operators we'll be covering are conjunction and disjunction, inclusive disjunction only. You may also know them by another name, and or. So to briefly cover these in JavaScript, and or are binary operators, meaning they operate on, at most, two values at once, and they are represented respectively by a double ampersand and a double pipe, like so. So binary operators have a left operand and a right operand. You can think of them as just input to a function. So just to cover these, and requires that both operands must be true for the entire expression to be considered true, whereas or requires at least one operand to be true for the expression to be considered true. Now, in JavaScript, there's a concept of truthy and falsy values due to something called type coercion. So, in this respect, these aren't actually true logical operators, but we won't get into that today. We'll only be operating on booleans. Now, we've discussed in past videos the idea of reducing or simplifying values using some operation. If you notice, I'm kind of a broken record about this. Well, this is no different. Just as with numbers under some mathematical operation, such as addition or multiplication, etc., booleans under some logical operation will evaluate or simplify to another boolean. Keep that in mind as we continue on, because we're going to come back to it. So let's start implementing and as a function. This function will accept a list of booleans and will reduce them into a single boolean using and as the operation. Let's scaffold it out. So we know that the array method reduce accepts two parameters, a reducing function and an initial accumulator. So let's think about the reducing function first, and we'll come back to our accumulator later. So we know we have a list of booleans as input to this function, called bools here, and we are going to be using the logical operator and on them to make sure that they are all true. Okay, well, let's start with this pattern we've been establishing in prior videos. I'm shortening the parameters accumulator to ACK and value to val here for brevity. This is how I usually start my reducing functions, and then I can always name them something more explicit if it's called for. In fact, because we know that the elements of the array is going to be booleans, let's name that second parameter bool, and perhaps that will give us more of an idea of what we need to do with it. Now, remember that we've said that we can determine the data type of our accumulator based upon the expected output of our reducing function. We expect either true or false, so it's going to be a boolean. So ACK and bool here in the parameter list are both booleans, where ACK will be initially the initial accumulator that we have yet to determine, and bool will be the current element in the array. So since both are booleans, we can simplify them using and. Let's go ahead and do that now. Alright, so remember that the output of the reducing function will become the new accumulator, and it will be passed into your reducing function the second time, the third time, for as many values as you have in your array. Okay, so what about our initial value? The second argument needs to be a starting point for this operation. It needs to be something that won't have an effect on the operation as a whole. So this is the part where I ask you, is there an element in the set of booleans, call it A, that when combined with another boolean, call that one B, under conjunction, that will give you B back? So that's a bit hard to parse probably, but there is. True is the identity element for booleans under conjunction. So we can start with that as our initial value since it won't affect the operation. Here, let me prove it to you. Okay, so our right operand is our supposed identity element, the one we're trying to test, and it's only an identity element if it has no effect on the left operand. So if you noticed, true is our right operand, and in every case, when combined with a left operand, another Boolean using conjunction, it just gives the left operand back, as you can see in our output below. So since true is our identity element, we can use that as our initial accumulator in our reduce function. Okay, so let's give this AND function a whirl. All right, very good. It seems like we have our expected output. So the way I like to think about this is that we're taking a list of Booleans and folding them in on themselves using AND. And so, in that respect, I like to think that the value of true has within it all the combined value or Booleans that it could possibly have under conjunction, which is only true. So, let's actually implement OR now. This will be a lot faster since we've already done a lot of the scaffolding. We can use this AND function and just change what we need. Okay, so we just need our initial value for the accumulator as the second argument of reduce here. So what would be the identity element for Booleans under disjunction? Pause the video and see if you can find out. I'll wait. Okay, ready? The identity element for Booleans under disjunction is false. So true or false gives you true back, the left operand. And false or false gives you false back, the left operand. So let's put that in and give this a try. Okay, so we got our expected output, and that's great, but let's ground this lesson with a bit of a naive but possible use case you might have. Let's say that you have some user objects with an isPaid field on them. Okay, so what if you needed to see if they've all paid? Well, let's use our AND function for that. First, we'll map over our users and transform them into a list of Booleans. And then we can call our our AND function with that. All right, very good. Yeah, so not all of the customers or users here have paid, right? So it looks like that worked. So we could even rename our AND function to something like all or all pass or something like that if we wanted. But what if we wanted to know that if some of our users have paid, at least some of them? Well, it would have to be the case that at least one user has paid, and that sounds like we can use our OR function for that. Okay, nice. It seems like that worked. So yeah, one of our users have paid, and that's so that ended up passing. So that about does it for this lesson. Okay, well, if you have any questions, leave me a comment below, and if you like the video, please consider subscribing, liking, and hitting that bell icon. Thanks, everyone.